10.5 is independent and dependent events. So independent events, they do not affect each other. Dependent events do affect each other. So independent events, all you're doing is probability of A. If you have two events, be probability of A times probability of B. For dependent events, you do probability of A times probability of B given A. This long line means given, means that has already happened. So a dice is rolled 3 times. What's the probability of getting 1 on each roll? So I would go roll number 1. How many times can I get a 1? 1 out of 6. On roll number 2, how many times can I get a 1? And does the previous roll affect my next one? Nope. So 1 out of 6, 3 times, gives me 1 out of 216, which I can turn into a decimal, 0.0046, so 0.46%. Super easy. A coin is tossed, then a day of the week is selected. What's the probability of getting tails, then a day starting with the letter T? So does what I flip affect what I'm going to draw for my day of the week? No, completely independent. So flipping a coin is 1/2, and picking a day of the week with the letter T, starting with the letter T, 7 days of the week, there's 2 of them, Tuesday and Thursday, becomes 2 over 14, which is 0.143, 14.3%. Jack has 4 Snicker bars and 8 Twix bars. He randomly chooses one, eats it really quick, then chooses another. What is the probability that both candy bars were Snickers? So, out of 12 candy bars, there were 4 Snickers. There's what he could pick on the first time. Now he eats it really fast, so how many are left in that bag? Just 11, and how many of them are Snickers? 3. So this is a dependent one. That probability goes down because he had already eaten one. If you do that, you get 12 over 132, which becomes 0.091, 9.1%. Bag contains 8 red crayons, 14 purple, 6 yellow, and 4 green. A crayon is selected, replaced, which means you're putting it back in the bag. Then another is selected. Find each probability. Purple, then yellow. So how many purples are there? 14 out of 32 total in the bag. There's still going to be 32 total in the bag because you left it in there, or you replaced it, you put it back in. And how many yellow are there? 6. So then you get 84 over 1,024 becomes 0.082 or 8.2%. Green, then red. How many greens we got? 4 out of 32. How many reds we got? 8 out of 32, because remember I'm replacing it. Becomes 32 out of 1,024, 0.0312, 3.12%. Purples. Purples, there's 14 purples. Remember I'm replacing it, so I'm putting it back in the bag. There's still 14 purples. So same number there. 196 out of 1,024, 0.191, 19.1%. Same idea with yellows. Now, using the same example, assume that the crayon, you pick it out, then you keep it, you do not replace it, and then you pick another one. So, for yellow, then red. Yellow, we got 6 out of 32 to start with, but now I kept it out, so there's only 31 in there. But there's still, we haven't picked out a red, so there's still all the reds in there, which are 8. So 48 over 992 becomes 0.048, 4.8%. Here's where it gets real tricky, people. 2 greens. So out of 32 to begin with, then we keep one out, so it cuts down to 31. Greens. How many greens we got? 4. We're keeping that one out, so it goes down as well on top, becomes 3. 12 out of 992, 0.012, 1.2%.